Let's go back up and look at the actual graph. So you see here the graph, there's the middle 25, the middle 50% goes from 20 to 25. Upper 25% of the scores are from 25 to 28. The lower 25 are from 12 to 20. Median score was 23. So these are some things we want to describe. Remember, in context. So the center of a box plot, you don't want to talk about the mean, you want to talk about the median. The median agility score is 23. That means half the girls had an agility score greater than 23 and half were less than 23. The range of the scores is 16. Notice that is a single number. We could say the scores ranged from a value of 12 points to 28, but the actual word range is a single number. So we say the range is 16, 28 minus 12. That is a measure of spread, giving overall spread. The middle 50% of the girls, which of course would be the area where the IQR is measured, the middle 50% of the girls had scores from 20 to 25 jumps in 30 seconds. So there's a fairly compact middle there. There was more variability in the lower 25% of the scores from 12 to 20 than in the upper 25% from 25 to 28. So we're talking about how the data is spread out. We can talk about IQR, we can talk about range, we can talk about quartiles. When we're talking about quartiles, we're talking about 25%, 50%, 75%, etc. We can use various things. Another thing we might have been able to say here is 75% of the girls had scores between 16 and 28. Okay, so there's just another example. Unusual features. One girl had a particularly low score of 12 jumps per 30 seconds. Now shape is kind of a tricky issue. We could look at this and say that the shape is somewhat skewed to the left. However, we don't ever want to say that it's unimodal or bimodal or anything about the peaks. So let me give you an example of why we can't say anything like that. So I'm going to look at this. This applet here allows us to calculate the median and the IQR. So there's the median value, there's the IQR marked. So that's the middle 50% of the data is between here and here. And we have a box plot up here and we have a scatter plot. So I want to look at some different scatter plots. When we look at this one, we feel like it's a fairly unimodal and symmetric looking, although there's a whole lot more data over here than there is over here. So it's probably a little bit skewed to the left, but it's hard to tell that shape doesn't just leap out at you from the box plot. So let's do some more random samples. Notice here it's a fairly unimodal skewed to the right. So we see that skew, but we don't know from the box plot if it's unimodal. We can't see that peak in the data. So don't ever talk about it being unimodal. You could talk about it being skewed left. Okay, here we see skewed to the right with an outlier. I want you to notice here what happened to the other whisker. Well, there's so much data piled up at 0 that the minimum value and the Q1 value are actually the same value, so we don't have anything sticking out to the left. Okay, here's another one. Notice this has a bimodal. This data is bimodal, but you can't tell that from the graph. So you definitely don't want to talk about modality, about the peaks in the graph if you're dealing with a box plot. We see a gap in the graph here, and we don't see it in the box plot because this number isn't far enough out to be considered an outlier. Notice that we have a fairly large range, a large IQR because the data seems to be clustered kind of at either end, so we have a big spread in the middle. Nothing, fairly symmetric there. There's another one where we see unimodal and skewed to the right, but the box plot only just says skewed to the right. There's another box plot. Try to see if there's anything unusual to show you. There's someone similar to one we had before. Now here's one where we could say the box plot is fairly symmetric because you see that the median's in the middle of the box and the whiskers are sticking out. Now that doesn't tell us necessarily that data is unimodal. In this case it is unimodal and symmetric with maybe the one outlier there, but you can't talk about that. Let me see if we see. Now here's one where we have two very distinct clusters of data with a gap in between. The box plot doesn't show that. The box plot just has this really extended period here, but notice this data is encompassing all of this data, so some from this clump and some from this clump does not show gaps. So there are some limitations to what box plots can show. they don't show shape well. So let's just kind of write some stuff down here. You can describe skewness. I once heard a student say skewity. I think skewness is a better word. You can describe skewness, but box plots don't show peaks, gaps, or clusters. So be careful when describing shape. So box plots don't tell us as much as a histogram or a dot plot tells us. So what are box plots particularly useful for? They're particularly useful for comparing two distributions side by side. So we're going to see that in our next example, and you'll need your calculator for that next video.